Okay, welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 7 from the January 2024 International A-Level Edexcel Pure Mathematics P1 paper, and this question here is all about graph sketching. Part A anyway is, and we're asked to sketch the graph of the curve with equation y equals 4 over x minus k, where k is a positive constant. We need to show on our sketch the coordinates of any points where C cuts the coordinate axes and the equation of the vertical asymptote to C, the vertical asymptote to the curve. Now, when you want to sketch the graph of any curve, the first thing you need to determine is what is its basic shape. All right, so you should be able to recognize from the equation of a curve its basic shape. Okay, so you have straight line graphs which have got the form y equals mx plus c, where you have x without any power of anything but 1. Okay, no squared, no cubed, not in the denominator, multiplied by a constant sometimes and a constant added to it. That's a straight line graph, have that type of shape. Okay, then you have equations of the form y equals ax squared plus bx plus c, which is called a quadratic type of curve. Okay, where the highest power is x squared, there's no x in the denominator, and it has either this type of shape here or this type of shape here, which is called a quadratic. It's a parabola shape, has either a minimum or a maximum depending on the value of this a. Okay, then you have also cubic types of curve, which are like y equals ax cubed plus bx squared plus cx plus d, where the highest power is x cubed, there's no x in the denominator again, and it has either this type of shape, up, up, or this type of shape, down, up, down, something like this. Okay, there's variations of it. You could have points of inflection and so on. There's different variations of it, but basically that's the basic kind of shape that you'll have. And the shape is determined whether it's this way or that way by the value of a. Then you have what are called reciprocal curves, which have the kind of look like this: y equals something over x. Okay, where x is in the denominator. Now this type of shape of graph has some sort of a discontinuity. It's called a reciprocal curve. There's certain values of x and y it can't take. Okay, so this is a reciprocal type of curve, and whenever you have x in the denominator, you end up with a reciprocal curve. And we can see here that this is definitely going to be a reciprocal type of curve. This type of curve here, where there's x in the denominator, and that's something important for us to know. Now, whenever you have a reciprocal curve, you have to work out what the asymptotes are. What are the values that cannot go into this function? So, for example, into this equation. So, the first thing we look at is we see what value makes the denominator 0. The denominator of any fraction cannot be 0, it will be undefined. So the value of x, which makes the denominator 0, okay, will be a value that is going to be where the vertical asymptote is. X will not be able to reach that value. So we look at the denominator and we equate it to 0. So when x minus k equals 0, we can say x is equal to k. So x equals k is the asymptote. This is one of the asymptotes. This is one of the asymptotes. This is the vertical asymptote. Okay, the vertical asymptote, which is what we had to write the equation on. So x equals k is the vertical asymptote. And we can see also here that if I make y equals 0, if I put y equals 0, what's going to happen? You'll have 0 equals 4 over x minus k. When you try to solve that, you get 0 equals 4, which is a contradiction. So that means y cannot equal 0. So that's the horizontal asymptote. Okay, so you have a vertical asymptote and a horizontal asymptote. Now, if, for example, there was a number added to this fraction on the outside, like, for example, 1, then y equals 1 would be the horizontal asymptote, because when y equals 1, then you'll get 4 over x minus k equals 0 again, and then you won't be able to solve it. So whatever number's added to the whole fraction, that y equals that will be the horizontal asymptote. Okay, so that's the way to work out the horizontal asymptote. In this case, there's nothing added to it, so y equals 0 is the horizontal asymptote. Okay, so now we have enough information to be able to make a sketch of this curve. So I'm going to do that now. So we have our axes, y-axis, the x-axis. So x equals k. Now k is a positive constant. So x equals k will be, this is the y-axis, this is the x-axis. X equals k will be on the positive side of the axis. So let's just do that here. So x equals k would be, say, somewhere over here. Okay, so that's x equals k. That's the vertical, the vertical asymptote, and you have another asymptote, as I mentioned, which is going to be y equals 0, which we're not actually told to show, but those are the asymptotes. So we know that the this is basically going to be of this shape over here. Let me just make that a bit clearer, a bit better as a curve. This side is going to go like this. Sorry, it's not very neat. It's a bit difficult with this pen here. Okay, that's a bit better, I think. Something like that. It's a bit jaggedy, but you should try and make it smoother than that. Now on this side, we know that definitely there's an asymptote going to be over here. So it's definitely going to hit the y-axis somewhere down here. And we can actually calculate that part. Okay, so I need to write that point down because it says where it crosses the coordinate axis. It doesn't cross the x-axis, but the y-axis it crosses there. How do we know when something crosses the y-axis? Well, we know the equation is y equals 4 over x minus k. So it crosses the y-axis as with any other function when x equals 0, because the equation of the y-axis is x equals 0. So we're going to have y equals 4 over 0 minus k, so y equals negative 4 over k. So that's the coordinates of the 0 and minus 4 over k. Let me put it on that side because there's nothing written on that side. So that's 0 minus 4 over k. That's the point where it crosses the y-axis. So that is the sketch of this curve. Y equals 4 over x minus k. Okay, so showing us gets equals. Okay, so we've written down the coordinates of the or the equation of the curve and the coordinates of the point where it crosses the axis. So that's how you can draw the curve. So you should know that y equals 1 over x will look like this. Okay, if it was negative 1 over x, it would look something like this in these two parts. That's all. Okay. So there we have the answer to this question. So we should understand how to sketch these curves, reciprocal curves, quadratic curves, linear curves, cubic curves, and exponential curves. I think that comes more in P2, but that's basically how we deal with that question. So now for part 2 of the question, I think I'm going to have to use some of this. Okay, so for part B then, it says, given that the straight line with equation y equals 9 minus x, y equals 9 minus x, does not cross or touch C, find the range of values of k. Okay, so remember this is y equals x over, 4 over x minus k. Okay, and that's the point k there. So given that the straight line with equation y equals 9 minus x does not cross or touch C. So 9 minus x would be a straight line which goes through 9 on the x-axis and the y-axis. When x is 0, y is 9. When y is 0, x is 9. So it's going to be like a straight line going something like this. Okay, go through 9 on both axes. Okay, so we got to find the values of k such that this curve does not touch nor cross the curve. So basically, what we got to do is we've got to solve simultaneously the equation y equals 4 over x minus k and y equals 9 minus x, and show that find the value of k for which there will be no solution to this equation. That there will be no solution to this the simultaneous equation that we form. Okay, so when we solve a pair of simultaneous equations, what we do is we substitute one of the equations into the other. So what I'm going to do is I'm going to write this as 9 minus x equals 4 over x minus k. Okay, so I've just replaced this y with what y equals from the other equation. That's always the easiest or the most sensible way to think about it for when it comes to other types of questions where you have to substitute into, like, where it's equations of circles. You get confused if you just say equate the two equations. That works here, but not in every case. So think about it in terms of substituting instead of y in one equation, what y equals in the other, and that will make things okay for you. So now we can solve this by, we can multiply both sides by x minus k. So we have 9 minus x times x minus k equals 4. When we expand this bracket, we're going to have basically 9x minus 9k minus x squared plus kx equals 4. So we have a quadratic. Okay, now let me write the quadratic so we have the x squared as positive. It makes life easier. X squared, and you're going to have plus 9x minus kx. Okay, sorry, yes, that goes on this side. And then we're going to have plus 9x. We're doing, sorry. Let me do that again. So we're going to have 0 on this side, so you have x squared. You're going to have minus 9x and minus kx, sorry. Minus 9x and minus kx. And then we're going to have plus 9k and plus 4. Okay, I've just, all of these change signs when I put them on this side. Okay, you just subtract 9x from both sides. You subtract 9k, you add 9k to both sides. You add x squared to both sides, and you take away kx from both sides. So we end up with this. So we can take out the minus x from here. So we have minus x times 9 plus k. Okay. And here we're going to have plus 9k plus 4. All right. So here we have x squared minus, in brackets, 9 plus k, sorry. 9 plus kx. You've got to be careful about writing k's and x's. They look very similar sometimes. Minus 9 plus kx plus 9k plus 4. So equals 0. Equals 0, of course. Okay, because it's an equation. So we know that this is a quadratic equation. And we know that when you have a quadratic equation and the discriminant, b squared minus 4ac, is positive, you have two solutions. So if I wanted to find the values of k such that the line cuts the curve in two places, I would solve, I would rewrite the discriminant, well, I'll take the discriminant from here and put that into this inequality, and I'd find where there are two solutions. If I wanted to show where the line is a tangent to the curve, then I would equate this to 0, because there will only be one solution. Okay, b squared minus 4ac equals, when it's equal to 0, that means the line is a tangent to the curve. So it'll give me the places where the line is a tangent to the curve. If I put b squared minus 4ac equals 0, that will show me the points where there would be only one solution. That would be where the line is a tangent to the curve. So it would give me two answers for k. There will be two values of k for which this would have only one solution. One when it's a tangent over here, the other one is a tangent over there. Okay, that would be the case where it touches the curve and doesn't cut through it. But we want to find the case where b squared minus 4ac is less than 0. When the discriminant is less than 0, then there's no solution to this quadratic equation, which means there's no real solution. No real solution. Okay, when there's no real solution, that means the line will not touch nor intersect with the curve, and that's what we want to find. It does not cross or touch the curve. So we want to find the case where b squared minus 4ac is less than 0. So in this case, our a is 1. A squared, remember, it's the equation of a quadratic ax squared plus bx plus c. Okay, so that's the quadratic equation. So a is the coefficient of x squared, which is 1. B is the coefficient of x, which is minus 9 plus k. Okay, minus 9 plus k. And c is the constant, which is 9k plus 4. So we want this to be true. where we want b squared minus 4ac to be less than 0. And we've got to find the values of k for which this inequality is true. So what we're going to do now is we're going to substitute these values in. So when you put this in here, the minus sign will cancel out. You're just left with 9 plus k all squared, right? Because the minus is going to be positive. Minus 4 times a, which is 1, times c, which is 9k plus 4. And we want this to be less than 0. So it looks like we're going to have a quadratic inequality to solve. So that's going to be 81 plus, when you expand this, you're going to have 9k twice, which is 18k, plus k squared. You're going to have minus 4 times 9, which is minus 36k, and minus 4 times plus 4, which is minus 16, is less than 0. So now if we simplify this, we've got k squared minus 18k, and we've got minus 16 plus 81. So 81 minus 16, 81 minus 16 gives us 65. So we're going to have plus 65 is less than 0. So we've got to find the values of k for which this inequality is true. Okay, so remember, this represents the discriminant of the of the quadratic. This represents the values of k for which the discriminant value is given. So we want to find when the discriminant is negative. Okay, so when we're solving this inequality, we're basically finding the values of k for which the discriminant is less than 0. When the discriminant is below this axis here, the discriminant will have a negative value, and therefore it will be such that those values of k will give us no solution for the quadratic equation that we formed. So now what we have to do is solve this inequality. So the first thing is to find what are called the critical values, which is find when does this actually equal 0. So we have k squared minus 18k plus 65 equals 0. So the first thing here is to factorize this. I think that this factorized with 15 and 3. With 15 and 15 times 3. No, that's 45. 65, 13 and 5. 13 and 5, that's the one. 13 times 5. 13 times 5 gives us 65, and 13 plus 5 is 18. Yes. So they're both negative. So k minus 13 and k minus 5. Okay, that will give us 65 as a product, and that will give us minus 18 as a sum. So that's the right value. So k equals 13 and k equals 5 are the two critical values. So if I just adjust this a little bit to make our diagram a bit more realistic here. So now I know that this looks like, if you were to sketch something in this form, it's going to be this type of shape. So it goes through the 0 at 5 and 13, and it's going to have this type of, it's going to look something like this. So we can see that the discriminant is less than 0 for the values of what? When k is between 5 and 13. Okay, if the value of k is between 5 and 13, the discriminant will have a negative value. Okay, so it says find the values of range of values of k. Okay, good. All right. So when k is between these values, then you'll have no solution to the equation. Okay, and the curve and the line will never touch. So to find where a curve or two functions intersect, we solve the equation of the two simultaneously. So this is y equals 9 minus x. When you solve these simultaneously, that tells you the values of x where they intersect. Okay, now so we want to we have this unknown, which is k, so we solve them simultaneously by replacing the y in one of them with what y equals in the other, and we end up with a quadratic equation which has k in it. All right, so we want to find the values of k for which this has no solution, which is when the discriminant is negative. So we set up our discriminant b squared minus 4ac. Now b is minus 9 plus k, and a is 1 and c is 9k plus 4. We put them into this inequality for the discriminant, and then we solve the inequality by first, we end up with a quadratic expression which we're going to solve this quadratic inequality. So we find where does this equal 0. Those are the places where the discriminant will equal 0. Those would be the two x values where you would have a tangent to the curve. Okay, the tangent to the curve would occur when x equals 5 and x equals 13. Okay, somewhere over there. All right, but we want to find where there's no solution, when the line basically is between those values. When the line is basically between those two values. Okay, so when the line is between those two values, that's when you're going to have basically no solution. There will be no solution when k equals 13 and k equals 5. Okay, so there's the answer to that question here. I hope that was clear. All right, was that the end of it? I think that must be the end of it. Yep, next is question number 8. Okay, so that completes this question. Other questions from this particular paper can be found in the playlist that will appear at the top of the screen over here. Other questions from the topic of, this is all to do with graphs and equations. I guess you'll find the playlist over here for that. And you can subscribe to the channel by clicking on this link, and the video that's linked over here tells you how to use my channel to find what you're looking for. Thank you for watching, and see you soon.